this value in Python. Meaning that if you have immutable data type versus mutable data type is going to be a huge difference because you're passing the reference to those objects in the memory. So if you have immutable data types, you simply sending a copy of that object to your function. If you are passing a mutable object to your function, then you're passing its address. So if you make any changes to that object inside the function, you changing that the original object as well. So if you remember the local scope versus global scope, remember that functions have their global scope. If you pass something and you make changes to that variable inside the function, it is going to be local to that function. This concept is different when you're working with immutable data types versus mutable data types. So let's see an example of that.
So I'm going to create a function def f x, and what I'm going to do is I'm going to say x equal to x plus 5, and then I'm going to print my x, okay? And then you can actually let me return it. So return x, and then here in my main I'm going to say, all right, so I have this value x, that is, I'm going to assign value 2 to it, and then I'm going to call my function f, and I'm going to pass that value to it. If I run it again, I'm not going to see any output. Why? Because I'm not printing the value that is returned from that function. So if a function returns back a value, you must make sure that you display it or use it somehow. So now if I run it, I should see 7 because I'm passing value 2 to this function. 2 is coming here, you're adding 5 to it, and then returning the value back to your function. Okay, so this fx is going to be replaced by that value. If I say, okay, here I'm going to say print x, okay, so this is before I call that function, before function call, and then I'm going to put it right after this function call. And as you see in this function, I am trying to change x, but this x again is local to this function because x is a mutable object, and you have to destroy its previous one and create a new one like create and assign a new value to it. So if I run it, I'm going to get before function call x is 2, after function call it is 7, and then we go back to x because we had a immutable data types, and whatever change you make here are not going to be applied to another function. Okay, so this thing is local to this function, that the changes that you make to x, and then the x that you have inside main is local to main. So if you change that object in a different function using the same name, that doesn't have any effect on your variable in a different function. However, this concept is completely different when you're working with mutable objects. Okay, so I'm going to create another function. I'm going to call it gx, and in this one I'm going to, my g is going to now be a list, passing a list here, or we have parameter, list parameter, or mutable. So keep it general. So we have a mutable parameter here, and then this one was immutable parameter. You see the changes that we made into immutable parameter didn't have any effect in our in the other functions. All right, so now let's work with immutable parameters. Actually, I'm going to call it LSD, just to like have multiple names for variables. And here what I'm going to do is I'm going to append something to my LSD. Okay, so I'm going to append orange to my LSD, right? I'm not returning anything, I'm just saying append something to this object. And then in main, I'm going to create a list, of fruits, and I'm going to send it to that function g. Okay, so I'm going to say g lsd, or I'm going to pick a different name, so my list, and I'm going to pass my list to that function. All right, and as you see, I'm not returning anything, and I'm just calling that function. All right, so let's see what happens. So if I run it, I'm not going to get any output. The interesting part is now here. So print before function call my list, and then I'm going to call it once after we call that function, after function call. All right, so now it's going to be very interesting because I'm having this list, I'm printing it the original as its original form, and then I'm passing this list to a function. I'm adding something to that list in that function, and I'm not returning it at all. Okay, so I'm just adding something to that function. And then I'm printing the function again after I call that function. So if it was immutable data, we wouldn't expect to see any changes, and we saw an example of that. So we passed x, which was value of 2, and then made some changes to it, and that change didn't affect our that variable in main. Okay, but now we are creating a list which is a mutable data type. You see, it has the name is my list, and I'm passing this list to this function, then I'm giving it a different name, I'm adding an object to that list, and then I'm not even returning it. Okay, and I'm trying to print it right afterwards. So now let's see what happens. Here you go, the object, the new item is added to my list. Okay, even though I did not return that value, even though I gave it a different name, and as you see, it applied my change to that object even though I made it in a different function, right? And that is a huge difference between mutable and immutable data type when you pass them as an argument to a function. If you're passing immutable data types, the changes that you make to that object are not going to affect anything that you have in your main function or wherever you're calling it. If you're passing a mutable data type, however, a mutable variable, then you're simply pointing to the location of that object in the memory. So if you make any changes, it doesn't matter what you're going to call that object. If you make any changes, the changes are going to be applied to it without destroying the previous one, creating a new one. So the change is going to be applied to that address, and the address is going to be same. All right, it is same for this variable lsd, it is same for this variable mylist. Both of them are pointing to the same location in the memory. So if you make any changes to any of those two, the change is going to be applied to the other one as well. Okay, does it make sense? If it doesn't, let me know, because for lab 12, problems 7 and 8, you need this concept. You need to understand how mutable objects will change if you pass them as an argument to a function. A simple visual illustration of that is, let's say you have a list, and let's imagine this is, for instance, an example of my list which I had in my main. This is the lsd that I created inside the function. Both of them are pointing to the same location in the memory. So if, for instance, I add something to this list, both of them are going to see that change. If I want to see their values, if I want to update any of its value, both of them are going to see that change. Interestingly, even if I create a new list, okay, so if I say new list equal to LSD, so I'm trying to make a copy of LSD and store it into this new list, okay, so now I'm saying append this to this new list and then return this, or not even returning it, so just do this. So I made a copy and I'm adding this orange to this new list. Okay, now we have like three different names. We have my list, which is my original one. I'm passing my list to this function. I'm storing it to this variable list. And then out from this one, I'm creating a new list and I'm adding orange to that one. Even if I do this, it won't make any difference because all of these are going to point to the same location in the memory. All right. And since they are all pointing to the same location in memory, if I change anything in that location, the change is going to be applied to all of them. However, if you want to make a deeper copy, you can say, okay, LSD list. Now you are making a different copy of that list and you are creating a brand new list. Okay, so now you have two different locations with the same numbers in them. And then so you're branching out. So from this point, if you add something to new list, that change are not going to be applied to LSD or my list. So now if I run it, my original list hasn't been changed because I used list copy. Okay, if you want to make a deeper copy, there are some other functions that you can use to make deeper copy, but I'm not going to get into the detail of that in this video.